framing is a set of flexural steel members equally spaced and rested on bearing walls. They are designed to support the loads affecting the roofs like dead, live, wind, snow, and other loads. In this tutorial, we are going to show you how to design a double span rafter in the new SteelSmart System version 8. To begin, from the home screen, we'll open the roof framing module and choose the double span rafter design template. The template opens with various design input parameters that need to be set. The user can assign the criteria and set up the roof geometry and model in any order. Keeping the name as Roof 1, in this example, we'll start by adding the span's projection length to the Geometry tab. Then, adding the rafter spacing, and this value will be multiplied by the loads to get uniform distributed load per unit length of the rafter. And finally, add the slope of the roof. Next, we'll enter the design parameters. Starting with the design code input selections, you'll notice there are options for the International Building Code and the Canadian National Building Code. For this example, the 2018 IBC is selected. ASD and LRFD design methods are available. We'll select ASD as the design method. We can verify, add, remove, or modify the load combinations for strength and lateral deflection. Normally, the default combinations would cover the requirements for the design. There are also options to design for web crippling. Depending on connection types or locations of concentrated loads and reactions, the web crippling check may be needed. Options for considering standard punchouts or web holes and the strength increase of cold work of forming are available. Next, we can enter member data for each span. To begin with member input, we can choose to design the member based on the inputs or select check safety to analyze a specific member. Moving forward with the design selection, we can enter minimum section dimensions and design criteria. The designer may have other space constraints or requirements that SteelSmart System can include criteria for in the design. It has options to produce design results based on exact rafter depth, minimum rafter depth, and minimum rafter flange width, or minimum area. The member type is then selected. SteelSmart System can design TSN jam stud or standard studs. We'll leave TSN jam stud for the member type. Then we can select the member layout. There are options for one piece, two pieces back to back, and two pieces toe to toe. For this example, we'll select one piece. Down the left side, we can move into the bracing inputs. First, adjust the lateral and torsional bracing spacings for axial compression top and bottom flange. In this example, we assumed all of them braced at 6 feet. Lastly, set the distortional buckling rotational stiffness value. Usually, if this value is unknown, it should be set to 0. Next, under Deflection Requirements, the absolute deflection, roof live/snow load deflection, and total load deflection limits can be set. Following the deflection inputs are the loads. Dead, roof live, snow, wind suction, and other loads can be applied to each span. Once we add the loads, we can review the connection data and inputs. Next, we can choose the connection for each joint from the stiff clips RT650, RT1300, AL, and HC clips. Now, we can solve the problem by pressing the Run button. The design summary will appear showing if each of the components meets the capacity and serviceability requirements of the design. In this case, they are. In reviewing each output section down the left side, starting with members, the software shows the design section, the actual and allowable forces on the section, and the serviceability check of each section for each span. Next, the Connections Output tab allows the design to review the clip design. The actual and allowable forces are given, as well as the actual and allowable forces for the screw that is used for the connection to the stud. Next, we can review the positive and negative factored and unfactored reaction on each joint in the design. The unfactored reactions for each load case can be selected from the pull-down menu. The designer is able to view the axial, shear, moment, and deformation diagrams for each load type of load combination and change the diagram units. These can be viewed in the roof framing model to the right in the main window. Finally, we can review and export input and output data in the report module. SteelSmart System 8.0 now allows the user to show and hide different sections of the report using checkboxes for each section of the report. If you want to return to this input data and make any changes to the design and resolve, you just have to unlock input and it will allow you to go back and edit input. Alright, that's it for this roof framing design example. For more of the latest information and tutorials for SteelSmart System, please visit www.steelsmartsystem.com.